Today I want to talk about the Theorem of Pythagoras, but I just want to give you a little bit of background about this guy first. Um, he is a Greek mathematician or scientist and also a philosopher that lived about 2,500, 400 years ago. He lived about 400, 500 BC, and he had a very interesting few things that he did and that he was involved in, and it's actually worth it to just go read up about this guy a little bit. Some of the things about his life and about his work that we still don't know today because he was very secretive, um, a very mysterious guy. He had this secret society of nerdy people. Actually, it's like the Pythagoras society, which consisted of scholars and students and teachers and like masters of certain fields and researchers and a lot of people that really did a lot of work in science, but all of their work they did in secret. And they researched things and they would find out something spectacular and they won't share it with the world. Um, so yeah, he's a very mysterious guy. But we know a few things about him that he did work in mathematics, in astronomy, in geometry. He worked with numbers. He was a philosopher. Um, and their society, the work they did with numbers is almost like a sort of a cult, little bit like a religion of numbers, a religion of mathematics. They actually gave every number its own personality. So the number would be masculine, it would be feminine, it would be perfect, it would be beautiful, it would be ugly, it would be charming, it would be. So they have every number have a personality and according to its aspects and sort of things. So yeah, that's some of the things you read about them is really, really weird, and some of the things is quite actually just fascinating. How they worked with numbers and they researched odd numbers and even numbers and prime numbers and triangle numbers and squared numbers and things like that, and just looked at the identities and the personalities and um, the things of every number and researched about that. And some of the things truly, really are really weird. But some of the things they believed and they saw the world like is quite fascinating and interesting. Yeah, and another interesting thing about Pythagoras is that he actually was one of the first people to realize that the evening star and the morning star is the same star, which today we know is Venus. But people thought it was two different stars, and he realized no, it's the same star, it's the same thing. So, yeah, that's quite awesome. Right. So, one of the most important things that we actually have the privilege of using of his work, because of a lot of his work got lost in their secretiveness. But one of the things we actually use today, and we use a lot, so you learn about this in grade 9, but then you really use this theorem a lot up until matric to work out side lengths whenever you work with right angled triangles, and if you need to find the missing side length, you can do so by using the theorem of Pythagoras. Right, and this theorem basically states it must be a right angled triangle. Right, so if I have a right angled triangle, if I square all of my side lengths, then the sum of these two squares will always be equal to the sum of the hypotenuse squared. Now, the hypotenuse is the big one, that's right across from the 90-degree angle. And the sum of these two squares of the other sides will always be equal to the square of that side, which is quite useful. So remember to check for a 90-degree and remember to square the sides. All right, and then lastly, when you're done, remember to check for units and make sure you've put in your units. Right, so if I look at a problem, all of these problems will basically work the same. So say, for instance, I've got this here. I must have a 90 degrees, so I can work in this triangle because it has a right angle right there. And I can work in this triangle because it has a right angle there. But I can't work in the big triangle because if I look at its three angles, I don't have that any of them are exactly 90 degrees. All right, so you need two sides at least to work out a third side. So can you see in this triangle, I don't have those two. I just have one side. So I'm going to start in this triangle here where I've got two sides. And the 10 is the big one, it's the hypotenuse. So I've got x squared and 6 squared should give me 10 squared. Okay, x squared and 6 squared together should give me 10 squared. And always state I'm using this theorem, and you can just write PYTH, that's perfectly fine. All right, and then I've got, I want to work out the x, so I'm going to take over this 6 squared, and it's going to become a negative 6 squared on the other side. So I just take over the 6 squared just like it is there. And then I just work out. So I've got x squared is 100 minus 36. And you're more than welcome to use your calculator if you're uncertain. But these are not difficult. It won't always work out with perfect numbers like these ones. You might have numbers that work out on commas and things like that. So then just use your calculator, but the basic procedure stays the same. And then 100 minus 36 is 64. Okay, so x squared is 64, and then I must just take the square root both sides. So the square root of 64 is 8. And this is definitely centimeters. Okay, so now I've got this one's 8. And now I've got two sides here, so I can work out y. Okay, so in this triangle, the big one is the 17. So I've got 8 and y. So 8 squared and y squared should give me 17 squared. I'm using the Theorem of Pythagoras. And then I'm just going to take over the 8 squared so that I have y squared alone. And 17 squared is 289. And 8 squared is 64. So 289 minus 64 is 225. And then I've got that y squared is 225. So y is the square root of 225 is 15. And that's centimeters. All right, and that is how I use the Theorem of Pythagoras.